I will choose 55, and then you choose the next. We just need to practice. I mean, we can move on, but I like to practice. Okay. So we're asked to find the definite integral of this function. Now, one thing that I want to make sure from the very beginning is that function must be continuous on, in this case, the interval 1, e. If it's not continuous, I will write fundamental theorem of calculus is not applicable. Okay, it's an improper integral, which we do not discuss in this class. So is this function defined everywhere? This is defined everywhere. This is not defined at 0. So yes, the function is continuous everywhere on 1 to e. So this is not the case. But I always have to check. So this is a major condition of the fundamental theorem of calculus. It's not applicable if the function is not continuous. So it is. So then I continue finding the antiderivative of x, which you already told me several times. And then plus, please remember what the antiderivative of this is. What is it?
Natural log of the absolute value.
Yes. Thank you so much. I will drop the absolute value because 1 through e, the interval is always positive. So, but I have to initially write it. So when I plug in e, I get e squared over 2 plus natural log e, which is 1, but minus, when I plug in 1, minus 1/2 minus natural log 1. But I know that I know that natural log 1 is 0, so there is nothing else I have to write. But of course, I have to perform these operations. 1 minus 1/2 is 1/2. So this is e squared plus 1 divided by 2. 1 minus 1/2 is 1/2. They have the same denominator. So always remember the function must be continuous on the interval. Otherwise, the fundamental theorem of calculus does not apply. Before we look at word problems, would you like to choose anything else, or I will?
Can we do 47?
Yes. Where is it? I see it. Okay, 47. And 47, we have integral from -2 to 5, from 2x squared minus 3x plus 7 dx. Let me check. Did I copy the right one? Yes, I think I did this time. Okay, so again, is this function continuous? Yes, this is a polynomial function. So I don't have to worry about it ever. So it's continuous, so it doesn't matter, right? So I have to find the antiderivative and evaluate it at 5 and subtract when I evaluate it at -2. So can anyone give us the antiderivative? So this is the f of x, and this is the uppercase f of x.
Thirds x to the third minus x to the third plus 7x.
So indeed 2, x to the third over 3 minus 3, x squared over 2 plus 7x. Excellent. So now we plug in 5. 2/3 times 5 to the third, 125, minus 3/2 times 5 squared, which is 25, plus 35. Minus, careful, I would recommend parentheses here, because you may forget to distribute this symbol. So 2/3 times -2 to the third, this is -8. Minus 3/2 times 4, that's okay. And then minus 14. Okay, so let's see. So I'm going to say 250 here over 3 and minus This is 75 over 2. Keep an eye on my numbers, please. This is a negative 16 over 3, so positive 16 over 3. This is minus 6, but positive 6, and minus 14, positive 14. Okay, I'm checking my numbers. 250 is correct, 75 is correct, 35 is correct, negative 16, yes, positive. This was negative 6, positive, negative 14, positive. Okay, good. Now, let's see what I do next. So this is 20. 20 plus this is 55. Okay. Now plus these two, 266 divided by 3 is not divisible, and minus 72 over 2. Okay. 75. Okay, so the least common denominator is 6. This one needs a 6, this one needs a 2, and this one needs a 3. And I'm just going to calculate it. So 55 times 6 plus 2 times 266 minus 3 times 75. I got 637. Correct my numbers, please, if you find anything. And I can't simplify by anything. Is this divisible by 3? No, it's not. So it was 6, 55 times 6, 2 times. Anyone got the same answer? Anyone checked? Okay, so let's continue. Other questions? Anything else? Anything else?
53.
Which one? 53?
Yes.
Okay, 53. The integral from a to b, from e to 2t dt. Perfect. Great. Okay, so remember what we said, that the integral from e to a, I'm not going to use a, let me use, well, it's fine. I mean, dt is e to a over a plus a constant c. But that's for indefinite. This is the general thing. So now I know how to do what is the antiderivative of this, which will be e to 2t over 2 from a to b. I have to plug in b, but I will leave the constant outside. Plug in b, e to 2b minus plug in a, e to 2a. You can leave it as is, or you can put it over 2. Same thing. And there is nothing we can do here to simplify this. Good pick. Do we need to practice more, or can we move on to word problems? Do we understand how definite integrals work and how they are determined? Oh, this is interesting. I don't know if you're interested in the credit market debt. Business increase total profit, increasing total cost. Who wants to increase the total cost? Unless something good comes out of it, I guess. Okay, we're given the acceleration and the velocity, and we're asked to find the distance. Interesting.
Can we do 85?
Yes, where is it? Distance. Okay, 85, good pick. Let's take a look. So So in 85 we have, okay, so we have the acceleration, a of t, of course, is negative 32 feet per second squared, correct? We are given v0 or v naught. Okay. Okay, so they are not giving us the numbers, but they're just saying v0 is v of at 0 is v0 and s at 0 is s0. Fine. And it says find the general expression for s of t in terms of. Fine. They're not giving us any numbers. They are just asking us to use just these. Okay, good. So in order to determine the distance formula, I have to first determine the velocity. I cannot go from the acceleration directly to the distance. I have to go through the velocity. I have to find the velocity first. So the velocity is the integral from a of t dt. So I replace it with negative 32 dt. The constant goes in front, and I have just t plus a constant c, because t prime will be 1. The constant goes in front, and t prime is 1. So now I am told that when time is 0, the velocity is v0. Well, that means that c is v0. So v of t equals negative 32t plus v0. This is the intermediate step. Now I'm trying to get to the distance. So then s of t will be the integral from negative 32t plus v0 dt, because s of t is the indefinite integral from v of t dt. Okay, so then this becomes 32t squared over 2 plus v0t plus a constant d, not to be confused with that. But I'm told that s of 0 is s0. 0, 0, these are 0, so then d is s0. So here's the formula. Negative 16t squared plus v0t plus s0. Very nice pick. Interesting problem. Any questions on this? Any questions? Anyone?
Can we do 86?
Yes, let's take a look at 86. Where is it? This one? See exercise 85. Okay.
Yeah.
Good.
Same thing,
They are paired. That's fine. So that's 9. 86. Okay. From a height of 10 feet, that is s of 0, so 86. S of 0 is 10 at an initial velocity, or v of 0 equals 80. How long will it take before the ball hits the ground? Okay, so then s of t is a negative 16t squared plus 10t plus 80. It's thrown from a height of 10 feet. Yes. I managed to reverse those, isn't it? Yes, of course. Okay, that's why I knew they said 80. They said 10, and then 80 was the velocity, right? Yeah. So 80, the velocity, and 10. Good. So now let's see what they want. How long will it take before the ball hits the ground? Okay. So by hitting the ground, we just know that s of t has to be 0. So all I have to do is just set it equal to 0. So a negative 16t squared plus 80t plus 10 equals 0. Multiply or divide by negative 2. That's the best. I have 8t squared minus 40t and minus 5. And then I will put those in the graphing calculator and just solve and see the time. Okay, where's my calculator? Right here. So get out of there, and then no, in apps, I forgot. Yep. Okay, so I want 9, and it's a polynomial. Yes, oops, that's what I want. And no, it's not that, it's this. And I want next. No. Oh, I want graph. Yeah. Okay. So 8. And then negative 40. And then it didn't like it. Why? It didn't like it. Why? Why it didn't like it? Okay, that is correct. That is correct. And I want the last one, negative 5. Please cooperate. Ah, so I cannot accept the negative solution. So the only solution is t equals 5.1 seconds. Okay. So it takes 5.1 seconds to hit the ground. Okay, anything else? Another word problem, or we move on to properties of the definite integral? I know we only have like 6 minutes or so. These require, let's see, we don't need to do this, but what I'm saying is I see what happens here. They're symmetric intervals. Yeah, maybe I should mention that to you real quick.